have a student who has a disability, I don't think of them any differently than any other student. I might have to use sign language, and my behavior will change somewhat, but in terms of their abilities to do science and engineering, I feel they can do it just as well as anybody else. Both my parents were deaf, and they both taught at the California School for the Deaf in Berkeley, where I grew up. Over time, I saw my parents' lives change because of technology. When captions got on television, boy, did that make a difference for my parents. I got my PhD in mathematics. That led me to do theoretical computer science. I kind of took that all in and started to realize that I'd learned enough that I could actually contribute to technology for people with disabilities. Around the mid-1980s, I got involved with the deafblind community here in Seattle, and I could see a real need for technology there. There's a lot of young people who have disabilities who could use support. They need support. They need to be able to get into science and engineering. I've taken the last part of my career and decided to make that happen. Disability, it's not rare. It's about 1/7 of the world's population. There are these greats of science and nobody talks about their disability. Not very many people know that Thomas Edison was deaf. Isaac Newton was epileptic his entire life. Albert Einstein was dyslexic. I think of disability as just a facet of diversity, and having people with diverse perspectives helps science and engineering get better. Diverse groups working on technology get better results. I recognize that an attitudinal change is needed, that disability should be thought of as part of diversity. And that's the way I've been working for the last 15 years in sort of that spirit. I've decided to have workshops for people with disabilities. Access CS for All is a relatively new project, and through that work, we're continuing the development of accessible technologies for youth doing computer sciences. Access Computing, it's an alliance, and we have about 62 partners currently. Most of them are other academic institutions, but we also have industry partners, and we've supported over the last 15 years almost 1,000 students. In the last 5 years, we've had 15 who have finished their PhDs. We just have to make sure that science is accessible and that it's welcoming to everyone.
If we are to solve the world's most intractable problems, the only way we're going to be able to do that is with science, with engineering. I'm the daughter of Indian immigrants. My parents came here from India, and my father received his PhD in electrical engineering at the University of Iowa. My mother, an entrepreneur. Science became part of our lives at a very early age. I started doing science fair projects when I was in middle school. My first science fair project was the study of duckweeds, and I became a science fair junkie. I ended up receiving a fellowship that allowed me to travel from Thailand to Pakistan for a year. And it was in India, where my parents are from, is where I say I had my moment of obligation. I was on a train platform in Bhubaneswar. I saw 50 kids sitting in a circle learning how to read and write. And these kids were obviously poor and destitute. And I thought at that moment, I had that moment of obligation of how do I help? And how come I don't see more train platform schools all over India? I decided to found the Global Fund for Children. And that organization is really about investing small amounts of capital into really innovative grassroots organizations that are undervalued and undercapitalized. The Society for Science and the Public is best known for three things: for our award-winning magazine, Science News, our world-class research competitions, as well as a suite of outreach and equity programs that reach young people throughout the United States. My work has been centered around opportunity. It's been centered around making sure that young people can reach their dreams. I'm inspired by seeing young people say, I can do this, or that I can actually solve a problem that's occurring in my backyard. So this community that the Society for Science and the Public is building, whether it's our readership with Science News, Whether it's our alumni base of our competitions, whether it's all the young people and teachers we're reaching through our outreach and equity programs, we are building a movement to make sure that science is front and center in everyone's lives.
I think I came out of the womb as a scientist. I've always been fascinated by the how and why of things. My parents indeed were my first role models. The energy that they would have generated knowing that their son was the 2020 Vannever Bush Awardee could only be measured in gigawatts. My first career early on in the early to mid 80s was in working to develop MRI techniques applied to imaging the cardiovascular system. I was fortunate to come along at a time where this technology was just emerging. And I was able to participate in its development. That technology has now evolved to be very commonplace and seen across the world. I was privileged to have been recruited to be the inaugural director of the National Institute of Biomedical Imaging and Bioengineering, commonly known as NIBIB. We challenge the community to pursue and achieve medical moonshots for the purpose of really solving big problems that affect a lot of people. My current career is as the CEO of InHealth and Executive Dean of InMed at Texas A&M University in collaboration with Houston Methodist Hospital. InMed is the first initiative within the broader InHealth umbrella. InMed specifically is the convergence, the blending of engineering and medicine in the same curriculum to train a new kind of healthcare professional, one who understands both engineering and medicine in an integrated fashion. And we call them physicianeers because indeed they are solving problems in health through engineering. To anchor this aspiration, we require our graduates to actually invent a solution to a healthcare problem by graduation. I don't think that there is any way that we will get to where we would like to be without having the kind of technological innovation that these physicianeers will bring to the whole healthcare ecosystem. At each phase of my career, the driving motivation for pursuing the convergence of the life sciences, the physical sciences, and engineering is that this is the most efficient path to solving some of our major problems. In nature, all of the scientific disciplines and engineering are seamlessly interwoven. Without all of these integrated in a symbiotic fashion, there would be no life. So it follows that our best solutions to our healthcare challenges are most likely to come from an approach that's similarly integrated.